This is part 3 of the video notes for Objective 4, Graphing Trigonometric Functions. In the last 2 videos, we learned how to graph sine and cosine using amplitude, period, phase shift, and vertical shift. Now we need to consider sine and cosine's reciprocal functions. In order to graph a reciprocal function, we're going to need to be familiar with graphing the original function, in which case we will then just reciprocate the graph. So let's consider the reciprocal of secant. Secant is equal to 1 over cosine. So if I'd like to graph 2 secant x by hand, I need to graph first 2 cosine x. Label our graph for an amplitude of 2 and a period of 2 pi. This particular example has no phase shift and no vertical shift and just a standard period. So let's go ahead and sketch what 2 cosine looks like. Cosine begins at its amplitude and ends at its amplitude. Now, to graph the reciprocal function, we're going to use the key features or the critical features that we've been highlighting in each of our graphs. From here, and it may help if we just consider a little bit into the negatives for a clear picture. From here, we want to consider reciprocating each of these peak points. So let's start with 1. If you consider 0, 1, the reciprocal of 1 is also 1. With an amplitude of 2, we get the same point at 2. So secant and cosecant share the ordered pair 0, 2. Then we consider the next point. What happens when you try to reciprocate 0? Well, 0 is also known as 0 over 1. And when you reciprocate it, you get 1 over 0, which is undefined, and a divide by 0 error. We're going to go ahead and draw a vertical asymptote through 0, since undefined reflects as an asymptote on a graph. The next point normally would be at -1. The reciprocal of -1 is also -1. With an amp of 2, it sends us to -2. Secant also shares the point pi, -2. The next point is again 0, whose reciprocal is undefined, which makes it an asymptote. Now, when you're reciprocating your values, what happens on the picture is that each curve is picked up in the other direction. Be sure not to cross your asymptote, because an asymptote is a boundary that the values will not reach. And then just match each curve in each portion of the graph. Well, we want to analyze the information on secant the same way we analyze the information on cosine. This secant graph has a period of 2 pi. It started with an amp of 2. No phase shift, no vertical shift, but you might notice that there's something new, the asymptotes, which we need to list. To list our asymptote, we want to start with the first location. The first asymptote in this graph is located at pi halves. Then every asymptote after that will be pi away from the original. So we write plus or minus pi n. This equation gives us the location of every asymptote on this graph. Let's take a look at our next example. For the next example, I've decided to add a period adjustment and a vertical shift to see how this is going to change the graph of cosecant x. Well, cosecant x is the reciprocal of sine x. So to accurately graph cosecant x, I'd like to sketch sine 2x plus 3. This graph will have an amp of 1, a period of pi, and a vertical shift up 3. Since the period pi fits on a 2 pi graph, I'm going to go ahead and label my graph with the same scale that I've been using. An amp of 1 with a vertical shift of 3 means my graph needs to go to at least 4 on the y-axis. And then match it on the x-axis, or the negative y-axis. And then I'm going to go ahead and sketch sine 2x plus 3. Well, sine 2x is a sine function that terminates at pi instead of 2 pi. So I'm going to go up to 1, down to -1, and back. One more time. Up to 1, down to -1, and back. I then need to take each of these points and shift them up 3 units. Now you can actually do the shift up after you've drawn cosecant or before. In this example, I'm choosing to do it beforehand, but it wouldn't affect your picture either way. All right, here's my sine graph, still dotted because it's still a sketch. And now I'm going to reciprocate it. Every original 0 is now an asymptote. And every min-max is still a local min-max. Notice, even as I draw these, I'm not crossing my asymptote. It's very critical that we keep this narrow in the channel and do not exceed the boundaries of the asymptote. Here is my completed graph of cosecant 2x plus 3. In the last example, I did not double check my graph with that on my calculator, but I think this is a good time to remind ourselves that we should be using our technology to make sure that our graphs are turning out the way we intended. Let's graph cosecant, which is 1 over sine 2x plus 3. Oh, close parentheses before you do the plus 3. Otherwise, the plus 3 will become a phase shift instead of a vertical shift. Adjust my window settings, 0 to 2 pi. This time I'm doing -5 to 5, and graph. As you can see, the graph on my calculator is nearly identical to the graph on my screen, or on my paper. The last thing I need to do that's unique to secant and cosecant, and tangent and cotangent, which we haven't seen yet, is label my asymptotes. The first asymptote in this example started at 0. I tend to include the 0 in my answer, but that's optional because, as we know, adding 0 doesn't do anything. And then every asymptote is pi halves away from the previous asymptote. So we will plus or minus pi halves n. And let's do one more secant and cosecant graph. For our last example, we're going to do a basic secant graph that has a phase shift and see how it changes our example, particularly the location of our asymptotes. To begin this graph, we need to do its reciprocal, which would be cosine x minus pi fourths. That tells me I have an amp of 1, a period of 2 pi, and a phase shift of pi fourths to the right. In the last example, I did the shift before I graphed the reciprocal. So in this example, I'm going to complete the shift after I graph the reciprocal, just to show you that it works both ways. With an amp of 1, I'm free to label my graph pretty much any way I want. With a period of 2 pi, although I have a phase shift, I'm going to keep my scale at 2 pi. And because the phase shift is pi fourths, I'm going to go ahead and label every pi fourths on my graph. Like so. Let's sketch this graph. Cosine starts at its asymptote, crosses the x-axis at the corner mark, bottoms out halfway, crosses again at the 3/4 mark, and ends at its asymptote. Drawing the reciprocal, which is secant, I'm still going to do it in a sketch because I haven't done the shift yet. I know that this point will stay the same. This will become an asymptote. This point will stay the same. This will become an asymptote. This point will stay the same. And flip it up. Still dotted because I need to move it. Still dotted. And the last thing I'm going to do is take all of these points and move them pi fourths to the right. So from 0, 1, I'm going to go to 0 pi fourths. From pi halves, 0, go to the right. Draw your new asymptote. From pi to the right, 3 pi halves to the right, draw your new asymptote. And then this one is off the graph. Connect your curve. This area, I'm going to have to guess how that looks, and I'm actually going to use my calculator to help me with that. This area I know goes up that way, goes up that way. I don't know exactly how far, but I can predict the next asymptote, which will be over here. That helps me draw a clearer graph. And then let's just take a peek in our calculator what this ending piece exactly should look like. So for this example, we were graphing secant, which is 1 over cosine of x minus pi fourths. Notice the pi fourths is inside the parentheses this time. Okay, this graph doesn't exactly look like what's on my paper, but that's mostly because I did not change my scale to mirror my new scale, which only goes up to 2.5. And there we have our graph of secant x minus pi fourths. Well, where are the asymptotes in this graph? X equals, my first asymptote is here at 3 pi fourths. And the next asymptote isn't until 7 pi fourths, which is a total distance of pi. And that concludes the lesson for graphing secant and cosecant. These graphs just hinge on your ability to graph sine and cosine, which we've been practicing in the previous lessons.